Well, and thanks for the invite. So yeah, I'm going to speak about the Class 153 visual inspection units, and I just thought I'd start with a slide about myself, so you sort of know who's talking to you. So actually, my job title, we're both kind of right on that because my substantive role is a senior engineer, but at the moment I'm seconded into a principal engineer's job. So we're both right there. But I joined the railway then in '96. Worked for Adtran Signal as a design assistant. Rail track folded, and so did my job. So I decided to join the Air Force for a bit and had a bit of fun there. But didn't want to make a career of it, and I thought it was time to do some proper work. So I joined Network Rail in around 2005 in what was then called the Examination and Development section. It's now known as Asset Information Services and Data Collection. I've been there ever since. Did a bit of a stint at Rolls-Royce, so I thought it might be the grass might be greener, but found it wasn't. So came back, and since then I've been involved in maintenance and introduction of new systems. And then in 2021, was given this project to look after. So what is it all about then? So in a nutshell, we've introduced well, first of all, we started a trial to see whether we could record S&C footage. We'd done something previously before a few years ago with an MPV, which was a kind of very similar vehicle, but and that was 5-10 years ago. Technology has moved on a lot, and the context of that vehicle and the way it became as a service was too complicated, too convoluted, and it basically died off. So it was parked for a bit. Things have changed, so we had to go with a new set of vehicles. So we're talking about video inspection of S&C, geometry measurement over S&C. We wanted something that would work at from 0 all the way up to whatever the maximum speed of the vehicle was. It could operate on all lines. It wasn't a possession-based vehicle. And we wanted to create some improvements over the traditional way of tackling this. So we wanted it a driver-only operation, everything to be nice and simple and easy and integrated. The accuracy of the data was very important, so we've really got that nailed. And we wanted to deliver the data very quickly to the end users, which was where the MPV failed. That was days. We're talking now hours. So that's kind of what I'm going to run through today. The catalyst for it all, which I'll sort of be familiar to the majority of you, knowing who I can see on the call today. But the big one was the unfortunate death of Tyler Byrne in 2020, who was a track patrolling technician on Wessex. And that really was the catalyst for us to be given the challenge of what can you do quickly to prevent that from ever happening again. The other things backing it up, not that it needed it, was the approaching ban on red zone working, the requirement for more dynamic geometry over S&C with things like the Sheffield derailment and various non-compliances around the country, and the support where it's going to be applicable for risk-based maintenance. So when I talk about the 153s and any of the other yellow fleet and what we've done over the past, I always like to get people to reflect back on the past a little. And one of the things that I did in the past was do a technology roadmap for one of my degrees, and it kind of highlighted to me that if we look at the sort of traditional move forward in technology, certainly in infrastructure monitoring, unfortunately, it's all been about accidents, and that seems to have been the main driver for change. So the big one for us was the Hatfield accident in 2000. That really created an investment in test train operations and gave birth to a number of things. So train-borne ultrasonics, digitization of track geometry, and a raft of investment that really took it out to a full service. And you can see there's been others since. So Grey Rig, that produced PLPR, Liverpool Street derailment when that was lack of geometry in station areas, that led to the MPV. vehicles still moving around today, and there's been many others since. So we're unfortunately on another similar journey here. Everybody knows about Hatfield, and I use this more as an example of where I want the 153 to follow or to learn from. So Hatfield, big accident, rolling contact fatigue, big disruption to the industry. And we can see that in British rail days, going back to the 60s now, rail brakes were kind of managed. It was up and down until we sort of got into the advent of rail track and things took a turn for the worst and become slightly mismanaged. Hatfield rail accident, and from that, a huge reduction in broken rails. Clearly, it's not just what we've done. There's been lots of things over the years that have led to that reduction that UTUs on the higher category tracks and then onto the lower ones were certainly, but there's been all sorts of things like changing dip alert actions and that kind of stuff. So a whole raft of things that have contributed towards this lowering. And some of the recent ones that the technical authority that produced this slide are suggesting have been like things like mild winters that have gave us an advantage that's perhaps a false one. So 153 is kind of a way of lowering these things, as well as making sure that we embark on the same journey of continual development and improvement. So what needed to happen then? So what definitely needs to happen, and needs to happen more in network rail, is we need to do things completely differently, quickly and efficiently, because things just take too long to action. And in this project, it wasn't allowed. We had 6 months to deliver something. So we quickly formed a project team with sort of engaged stakeholders from Southern and Eastern, specifically Wessex and Anglia, were the two partners that were really behind this. And we made sure that they were involved in it at every stage. So we introduced things like weekly steering groups for operational, technical reasons, very early engagement with end users. And one of the things we quickly did with Colin Kavanagh on Southern was develop an output-based specification. So that was something we've not done before. We're normally dealing with network rail standards that tells us what we need to do, when we need to do it. This was very different. This was about quickly what are the factors that can lead to improvements, and that produced a very simple specification that went out to the suppliers. It was literally an email. It was that simple, and we directly engaged suppliers that we knew held technology that could bring this together. Were prepared to work in a different way and were agile enough to support becoming involved in something that wasn't very clearly defined at the start. And I'm happy to say that, you know, it's worked out very well. So based on what we wanted, we're again very quickly able to develop a vehicle and operating specification. And we went to Porterbrook, one of the big rolling stock owners. And to be honest with you, there wasn't much choice. The 153s were coming off lease with a few of the operators, mainly because they weren't meeting the persons with reduced mobility regulations, and were going to be too costly to modify the vehicles to meet that. So there's a lot of them sat around. Not perfect, 23-meter vehicle has its gauging problems. I would have preferred something a bit shorter, but it really was beggars can't be choosers. So that's what we got. And we went to Burton where they were stored and had a very quick assessment of what was there and picked 3 of what we thought was the best. What was also very apparent from the start was that we couldn't do anything sequentially. We couldn't wait for decisions to be made. So we had to launch a load of parallel work streams right at the start, work at risk, everything that seems to be quite difficult to do at the moment. So we took 3 Class 153s on an 18-month lease. 2 of them were converted into inspection units, and the 3rd was used for training drivers up. So we started training the drivers up right at the start, even before the vehicles were converted, so that we could run the trial straight away. Got the multi-company project team set up, and we had very regular meetings to keep things moving quickly. It was a real like sort of agile project where we had bursts of information, people would go away and do things, come back, everything you can really to speed things along. And we also made some very early decisions about the autonomy of the vehicles and the fact that we wanted to learn from some of the shortcomings of the current fleet. So we wanted integration in the cloud. We didn't want data sitting around on vehicles needing to be moved around, and the interface to be web-based. So another struggle we have in Network Rail is onboarding software. It's very difficult. So this was to be an externally provided interface as well for speed. Fairly quickly, the requirement for geometry was added to it, specifically from Eastern, who were working on an OR improvement notice for the Sheffield derailment. So they were very keen to see dynamic geometry over S&C. They didn't care that it wouldn't meet any of the current standards. They just wanted a way of very quickly assessing how the geometry of S&C was in an area. So I've probably made it clear, but we've kind of worked differently at every stage. If something was too complicated or time consuming, we found a faster way of doing it. We asked somebody else who gave us a positive answer. And as I've put there, it can upset a lot of people. And to be honest with you, it did, and it still does. But things have got done, which has been the main thing. So just to give you a glimpse into the kind of parallel activities that we did. So straight away, common safety method assessments for risk evaluations as significance tests. We needed to know straight away the route that we were likely to have to go down for this to be approved and become something that would be of value in the future. Gauging assessments as well were big and are still ongoing today, but we got them started really early. We created a new gauging model for the vehicle, and in fact later on it became a subclass of the 153, so 153/2. We involved local engineers there. I know Ian Ross is on today, who'll be very familiar with this on Southern, but the same his counterparts on Eastern started running assessments straight away. Mapped all the dependencies of engineering change and vehicle compatibility out as well. So again, we very quickly knew which paths we need to follow there and could plan for it. Lots and lots of hazard workshops with subject matter experts. So that helped progress the path for the common safety method assessment and then the future for it. Lots and lots of CAD assessments. We did loads of modelling, something we don't normally do. We tried out different ways of fitting stuff together, looked at susceptibility, did aerodynamic modelling of various parts of it. A lot of the stuff that until very recently we've found out only when the vehicle's been in operation. So we've learned from that and we've introduced it in this. We knew we needed to experiment with vision technologies, so the design was all about creating something simple that could be adapted and change and test lots of things. And again, operations and planning, again, another important thing, making sure the vehicles can operate where they need to. And there's been lots of support, especially in Wessex on that as well, on those early days, getting us moving around Eastleigh. And the emergency rescue procedures that probably don't sound very much, but 153s are not a regularly ran vehicle anymore. You have to consider about if one of these vehicles with a single engine breaks down, how are you going to get it off there? So on Anglia, for example, we had to have the driver trainer unit stationed at Norwich for a bit for the event that we did break down while testing, and it could go and drag it out. A bit easier on Wessex, where 158s were running and would be compatible. So a lot of the tech and a lot about the trains is quite difficult to explain. So yesterday we had a few of the vehicles around and I got my GoPro out and I've done a bit of a documentary on them. So it's quite long, it's about 12 minutes long, but I think it's the best way to sort of show you the vehicles, what they look like and how they are. So shout up if I've not included the computer sound on this. I'm pretty sure I have. But here we go, bit of a David Attenborough job. So this is VRU3, which was one of the first VRUs that were converted, and it's still in the sort of Mark 1 specification. So these vehicles, they've got three cameras mounted on the old door, a standard sort of forward-facing high-definition camera that was originally conceived to represent the same sort of head height as a patroller, and would be that sort of view that you would get walking down the track. And then the cameras above it, there's two there, one of which is a thermal IR camera, which has proved to be very useful and very effective, both with infrared lights underneath them and a pair of infrared lights on the front of the vehicle as well. And you can see the two lower pods, that was the first arrangement, and really chosen just to offer a quick way to evaluate cameras and views. So two pods over each rail, one looking at one side and the other looking at the other. They've also got their own individual IR illumination within them. So something we quickly found was that the IR illumination was not really good enough and didn't provide enough image clarity, especially at night and especially at speed, which gave rise to the modifications that we'll hear about in a bit. The other thing we didn't have with this was a 4-foot looking down view, which was something the patrollers felt was necessary. So a modification we made on these was to introduce a 4-foot camera. This was the 4-foot camera arrangement that we came up with a pair of lights and then a centrally mounted camera there with a wide-angle view on it, and that really improved image quality, illumination especially, and really gave us a good way forward to build on. So this is the other end of VRU3, then the sort of non-instrumented end, and we just got the single camera enclosure there with another forward-facing unit and a smaller one below it. That's just the image from that just feeds into the sort of overall forward-facing video library that we've got in Network Rail. Okay, so we've stood out the frontier of VRU1, which is the first of the vehicles to receive the video system upgrades. These ones just have a one end that's got the thermal IR camera and a standard forward-facing high-definition video. You'll see that the front of this one has none of the lower pods. They've been moved underneath into a new position. Okay, so we're underneath the vehicle now, and just stood behind the trailing axle of the number 1 end bogie, and you can see then the arrangement of cameras that's been introduced with this new system. So you can see there that we've got 3 cameras pointing straight down. The pods have got the lids off them just at the moment while we're setting them up, but those 3 cameras basically will cover the 4 foot and an extent to around 700mm outside of both running rails. So you'll get a really wide-angled 4-foot view. Should capture any S&C componentry that you've got on the end of sleepers. And then we've got the 2 inner and outer rail-facing cameras on both sides. So the outer one, not much change there, still looks at the outside of the rail. But the main change we've made is that these inner camera pods here now focus in on the opposite side of the rail, so you'll get a much better view of the opposing rail. So you'll be now looking at something like that compared to what we had before, which was a much steeper angle and wasn't giving people the view they required. Just a bit of a graphic there that shows you the cameras and how they look. So a number of improvements there. You can see at the back there we've now got a light bar which covers the full width of the cameras, so it's visible light, so that will be illuminated and provide much better image capture. We expect the sort of imagery that comes off these vehicles to be kind of similar to what you might find on the PLPR vehicles. So the other component that's fairly, well, it's completely similar to all of the other VRU vehicles is the geometry system. So you can see this is literally mounted smack bang underneath the bogie, and its focal point is sort of halfway between the wheels of the vehicle. There's the main sort of beam here that goes across, and on either side you've got these two modules here. So it might be difficult to see here, but you can see a window there, and there's another one on that pod over there. So there where the cameras look through, and then this central slit in here behind there is the laser, which illuminates the profile of the rail and where the system picks its gauge corner up from. So one of those on both sides, and on top of the beam you've got this inertial measurement unit that contains accelerometers and gyroscopes that feed into the geometry measurements and capture from the systems. So we're sort of in the final throes of approving the geometry systems on the vehicles now, and we expect within the next couple of months to be able to offer a compliant recording service. So the final sort of main bit of kit on the bogie is this rail lock unit that we're looking at here. So the sort of yellow centre of it, that's a light, and then there's two cameras either side of that light. As we've mentioned before, this is the positioning system for the vehicles, so we no longer rely on GPS acquisition and then map matching for position. What this system does is it illuminates the forefoot, and those two cameras are special types of cameras that are used to extract features. So that records a picture which is then easy to extract features from, and those features can be the way that the ballast is arranged, the arrangement of sleepers, clips, nameplates, cabling going across the forefoot, anything that's anything that performs a feature really, and from this data a fingerprint's removed from it, and then that's loaded up into the cloud. Within the cloud there's a positioning service that compares that against a previously positioned fingerprint. There's a load of feature matching algorithms that run, and from that it can return position. So all the data on the vehicles is post positioned. We're going to get that down to an hour, so the turnaround from recording to positioning will be an hour, and we've had that signed off now with data accurate to 3 centimeters. So fantastic bit of kit, real step change in positioning across the fleet, and will be particularly helpful for S&C inspection, where the run-on-run comparison of data on an asset that's not particularly big compared to plain line will be even more important. So as part of the upgrades, not only to the measurement systems, there was all the vehicles are due a C6 exam fairly soon. So while we were doing interior work and conversion, we've also done a lot of the C6 jobs on the inside of the vehicle. So you can see they're all sporting a new shady grey inside. We'll go into the instrumentation area, which is now also going to be standard across the fleet. It's a little bit dark in here, but you can see there's a big tank here, and that now houses the air reservoir tanks that were originally on the underside of the vehicle. They've now been moved internal into all the vehicles as it creates a bit more space on the underbody. And there's 3 racks there which are just semi-populated at the moment with the kit that's on board. So the main thing in here is the generator. So all the systems of all the trains have got a sort of powerful generator system, which is housed in that yellow enclosure, and they all work with a common electrical system. So the 3 boxes there that you can see, they're full of lithium batteries. and over here we've got like an intelligent charger inverter unit, and all the equipment that puts that online. So the trains never turn off. When the driver starts the train's engines, the generator starts and powers all the equipment. And when the train's engines are turned off, the batteries take over and they keep the kit on permanently, or until they lose charge, at which point they signal the generator to restart, and the generator starts for the time that it takes to charge the batteries up before turning off again. There's a sort of primary and secondary load shedding arrangement that's programmed into the inverter. So when the train's not moving and the main engines are not on, all of the power hungry parts of the systems that are not needed, like the lights and so on, are turned off, and it's just the comms and the main equipment that are kept on. So you can upload data around the clock, and you can dial in remote changes to all of the systems. You can also remote in and turn the generator on and off as well if you wanted to fault find various things. So that's a standard setup. These new upgraded trains then, so we've also got an upgraded messing area. So there's a CET toilet fitted, sort of reupholstered seats, a small kitchen, and just a small locker. One of the other sort of parallel activities that I mentioned was emergency arrangement. So there's an emergency coupler that's in a saddle there, which can be deployed if necessary. So just to finish off then, we've got another 153 379, which is going to be known as VRU5, and that's going to be a PLPR equipped vehicle. It's going to have the same track geometry system, but also a plain line pattern recognition system fitted to it. So this vehicle's just had the interior modifications done to it, and the interior upgrades, and is now being commissioned. So the next couple of weeks the PLPR equipment is being fitted. So at the moment there's just a lot of brackets that have been welded to the body and various places for the equipment to be stuck onto. So we're expecting this to start operating with another 153 just as a resilience vehicle in around sort of 2 weeks time, and then gradually over the next couple of months we're going through a validation process and get sign off, and then it can start to contribute to the overall PLPR recording plan. Okay, so not clearly not quite a David Attenborough documentary there, but he's perhaps not got the budget I was working with, and he's had plenty more practice as well. So there we go. I thought that was the best way of showing you the trains, because you know, pictures are just so static, and you don't get a feel for how things really are. So yeah, we did have 3 separate trains in that day as well, each slightly different, so it worked out quite well. So what I'm going to share next is a couple of the images that are coming off of that new arrangement of cameras. And first, you can see a crossing nose there. So that's the sort of, without seeing what the old ones were like, they were pretty good, but these are just that much better. So that's with the image not fully zoomed in, but clearly you would be able to pick up cracking and that sort of stuff off there. The other view that was talked about in there then was the side-on view, which is became very important and what really drove the upgrades. So that's the zoomed out view of a crossing that you get from that new side-on view. Slightly more zoomed in, so you can really see that you would be able to spot damage pretty well on many other components as well, not just the nose, of course. Other thing that was lacking previous as well was a really good view of a stretcher bar, and I know that looks quite confusing there, but once they've used the interface more, you become quite adept at using it and been able to pick stuff out. So the MPV, one of its downfalls is it never had a full view of a stretcher bar, which was one of the main requirements. And again, another end of a set of points there. And one big circle, the guys that produced the output had sent me this image asking me if I thought it was a problem. But I think it's just a bit of grease that's dropped down there. But you can see how high fidelity the images are now coming out of it. So it's looking good. So I'm going to speak a little bit about the tech on the trains. I know I covered some parts on that video, and there is another video in a sec. But the first one up then is the interface. So AVA, automated intelligent video replay, is a product that's supplied by One Big Circle. They're a startup based out of Bristol. And we use that interface to display our information. It's currently used to display forward-facing video information, but we've created a new area on it for displaying this. And there's a video now, just a couple of minutes long, and it'll show you how the interface looks and some of the other tricks it can do. No sound on this one, you'll be glad. There was quite a bit of background sound on the other. But as I say, the interface is web-based, so you can log in from anywhere. And this just gives you the standard sort of forward-facing view that you get from all the vehicles, and you can check your position on a map. But what we've done is create this inspection interface, which is the same, but you get a top-down view of all of the imagery, and you can compare that against other videos that are captured. So you can see the IR and forward-facing elements there, and you can go through and annotate and collaborate on the platform, so you can share images with other people, get feedback, make bookmarks, and constantly refer back to places that you regularly want to go and take a look at. So again, this view might be suitable for people just taking, general surveys of track and condition, checking stuff out without doing an actual patrol, for instance, which is what we built the system to ultimately complete. So this is where we get into our part of it. So integration of track geometry was one of the asks. So we've produced a viewing system that allows you to look at geometry while also playing real-time video. You can do run-on-run comparison with this as well, and then have whatever channels you want displayed up there. We've got position along the bottom. And also look at it again alongside the rail inspection imagery. So there's a little bit about the thermal capability as well. So each run goes through a processor that spits out thermal triggers based on some thresholds that you can configure. So found something there that's quite hot. It's come up as a trigger. So we can jump into the inspection imagery now and go and have a look what it is. You can see now there's a bond that's got some problems with it. I've found quite a few of these as well. And this is what we've built as the patrol interface. So what you're seeing at the top there is a digital track patrol, and someone's logged into this patrol now and is basically starting to perform an inspection on it. This bit of footage doesn't have the new camera views. That's been integrated at the moment. But as you can see, you go through, do your patrol, you find something you don't like, add it in, and it automatically populates a TEF form, which is what a patroller would be filling in as you went through. So the interface marks your progress, and at the end, when your patrol's complete, you print off your TEF, and off you go. So the next bit of tech then I mentioned in the video is the rail lock system. So this is really new, and it was developed by a team of guys called Machines with Vision. They're based in Edinburgh, and they brought across expertise from mobile robotics and actually automated vehicles, and they've applied that to the train industry. And we've had a trial of it now on the NMT for a good year or so. So it showed promise, but there wasn't quite the place to deploy it. And this was perfect to it because you know, a lot of your time might be spent under station canopies and in areas of poor GPS coverage where you just can't rely on normal position. So I think we saw the deployment of how it looks on the train. So it uses cameras that are event cameras that work slightly differently to normal cameras, which you know, might scan a line of footage at a time. These cameras respond to changes in brightness and color. So it means they can run at very quick speeds. You don't quite get an image of it that looks like normal. We'll see it in a second, but what we're going to see here is the image that's being taken real time versus the pre-positioned image in the cloud. And this algorithm runs that looks for matches between the two, and then you know, when they agree, you know, you're in the right spot. So it's constantly doing this. The fingerprint in the cloud, as I said, has been pre-positioned. So all these systems on the train are synchronized with a certain time code, and each of the vendors of those systems send a positioning request to the cloud that says, at this time code, tell me where I am. And of course, there's millions of these happening over a run, and each time Machines with Vision will return a batch of positions that then get integrated into the data. So everything's nicely synchronized, and as I say, 3 centimeter accuracy average. It does get better than that. See, this is the sort of speed that it's running off, and you can see things darting past in the background like bits of S&C. And it picks up on all sorts of features. Generally, the way the ballast is positioned, and it can account for changes in that in the future, so it doesn't need to produce loads and loads of matches. So if there was a tamper ran through and it tamped the ballast, there was plenty of other things that do still remain there, and it would rely on those. The new footage would be uploaded into the cloud, and it would sort of self-heal itself. So it's constantly relearning its new environment. It's a real great bit of kit. So we use the infrastructure network model that Network Rail maintains as our sort of positioning reference. And what we do when we go out on a new run is we use a high-grade GNSS receiver with an inertial unit coupled to it, and we sort of do a mapping run. So we'll go out and map it. That footage will then be uploaded and positioned against the network model, and that'll form the base fingerprint that will work from then on. So the final bit of tech to talk about is the Vista geometry system, and also a new company that we're involved in now in the project called VisioStack. So they're an American-based company, that really specialise in insights-based information. And we're building a data pipeline with them. And what we're going to do is we're going to stream position geometry information to this service, where it'll be validated and then automatically reported on if required. So there's a bit of a nifty graphic here, but it's sort of basically as I've explained, and there's going to be lots of data points flowing into the cloud. You can then customize your workflows and do whatever you want with them. There's a number of filters that it passes through, so it checks that the outputs of the sensors are performing as expected, and therefore validates the output before moving on to reporting, and then latterly displaying the information to the end users. So we expect this to be a bit of a game changer, really, in the way that our service has been run traditionally. So these are just a few slides now that sort of show you the processes that are going through. So first of all, as a data set comes in, it's assessed for its quality. First of all, positional quality. So it'll do checks to make sure that the frequency of data capture is expected. It performs well again against another mapping process that will just really go to verify that the machines with vision stuff is still working. Because we want automated notification of issues with this. We don't want to be seeing data reported to us by the end user as being bad. We want to only give out good data. The next part is the actual data quality that I mentioned. It's assessed for the actual quality of data. So, and anything that it reviews as being suspect, it is flagged and removed. Similar process with sensor output there. So we're looking at a cross-level examination there, and it's detected that the frequency of that output is not right. So it highlights it, and where necessary, removes it. You can customize your workflows very differently. The way we intend to run it is that we will position the data set. It'll then go into the VisioStack cloud to be validated. And when it has been validated, we'll pass a copy to Network Rail's Insights tool that can use it for the sort of big insights work. Another copy will be passed to One Big Circle, or then display it in the interface. And then another copy will be used for onward processing. So should a data engineer, track engineer in the route say, right, whenever you run over this stretch of line, I want you to report it, we'll set a rule up that says, well, whenever it does, we will report it. And that'll be done automatically. And sort of what you get out the end of it is defects, basically. Your defects as you'd see them now. So it mirrors the exact reporting process that we're currently following Network Rail. But the level 2 defects are exported as candidates. So very much in the same way that a PLPR session works at the moment, where defects are then presented to an inspector who decides whether or not they're correct and whether they should be reported. We aim to do the same thing. So in the future, this could be guys on the ground logging into the system to look at past recordings. It could be the data people in Milton Keynes accept and reject faults. So we expect it to really speed up the current process of track geometry recording. So kind of next steps with the whole service. So at the moment we're sort of transitioning into business as usual in Eastern and Southern. Both areas have nominated areas for expansion. So looking at moving into Sussex and potentially Kent, and Eastern as well. We've got sites nominated there in all 4 routes. So we're going out mapping. We're going out training the users to use the AVA system and get feedback. And really, we're looking to roll this out into other routes and regions if the pull exists, which is the big thing. You know, we want the service to sell itself. Currently going through the sign-off process to have the track geometry output validated. so there's confidence that it's meeting the output requirements of Network Rail standards. And as I mentioned in the video, we're currently working on a PLPR option, which is going to be used to help improve the service of PLPR in Anglia, which is an area that's struggled in the past. So it's going to be used to supplement that. And we're also looking at fitting ultrasonics to the vehicle as well, so we can combine all of this with an ultrasonic service. Other areas of interest are potential SVI inspection, so supervisor's inspection, and other types of S&C inspection that are being used. So there's some robotic solutions that are being trialled at the moment in Sussex, an Italian company and their product called Felix. So there's investigation as to whether a similar sort of system could also be fitted to a 153 and offer more detailed inspection types. So what do I see as the future? Really, for me, it's the insights, power. Visiostat specialise in that, and whilst we've not asked them to include that as an output, they said they're going to provide it as anyway to show us what can be done. And I sort of see this as, you know, we would be good to do tactical deployments of this new way of working. At the moment, people are doing the day job the way it is, and are firefighting. We're hoping we're going to be able to create this sort of parallel world with the outputs we're providing that will allow people to move into a sort of predict and prevent future nice and smoothly. Other things we can do is use machine learning to assist with other tasks. So there's lots of other things happening like that at the moment, using some technology born of the 153s on conductor rail in Wessex. There's a trial there where machine learning is going through and it's being trained to measure gaps and pick up missing components. So there might be the ability in the future to offer the same sort of service to users that are doing BVI and SVI, that kind of stuff. And structure inspections as well. So the cameras and technology, people are interested in seeing whether that could do structure inspections at the same time it's doing S&C inspection. So rather than looking down, it's looking up, again, offering the same sort of interface to help them complete those sort of tasks. So there's lots going on. It was a bit of a whirlwind tour. I was aware that I needed to be quite quick because of the time. I hope it wasn't too quick. I'd like to ask if anybody's got any questions.
Thanks very much, Brendan. It was a whirlwind, but an absolutely fascinating one. And I fear we're going to be really stuck to have enough time for questions. But let's see how we get on. Would anybody in the room like to ask Brendan a question on the presentation at all? Yes, please.
Excellent talk. Just one or two basics to start with. What was the cost of the project, and were you required to provide a business case, or was this technology and safety led?
Yes, that was the big thing about the project then. So it was safety led, and it still is. So it definitely wasn't a matter of cost is no option, but some of the discovery was finding out how much this deployment would cost. So we are talking a couple of £1 million to achieve all this. So not cheap, but hopefully plenty of benefits to show for that. And a lot of those costs were involved in the initial design and that kind of thing. We've now got the template, so moving forward and replicating it is actually quite cheap. You know, I hope that kind of answers your question there.
So I'll just jump in, Brendan. I think the one thing is we never forgot what caused us to make that step change and accelerate it, and that was Tyler. And we don't want to kind of often reflect on these things, but we have to, because it's the incident that was the catalyst, and we didn't want to let any network rail process, any funding challenge, anything get in the way of advancing to really make sure that we don't have another one. And you can't keep that far from your mind, because none of us want to be in that position again. And if this stops that, I mean, £2 million in a network rail budget is peanuts. And, you know, we kind of step through all that because we all have a common goal, which is boots off ballast, safety led first. And then absolutely harness technology. So this is a blank sheet of paper, what tech is out there to really make that transformation rather than iterate on top of what we already had.
Okay.
Thanks, Colin. Anybody else?
Yeah, I wish it was about in 2013 at Liverpool Street, because I can remember talking to the then head of track about what we had available. So he came up with some MPV with a couple of cameras bolted on the bottom of it. But no, really fantastic what you've achieved and what the team's achieved. And it's I wish I was about to play with something like this now, because it looks fantastic.
You can come out if you want.
How many of these would you need to cover the network? Has anybody looked at that?
Well, it's a good job Colin's there, because I can refer quite a few questions to him. But I'll start by saying that you can cover quite a lot of ground with these during one shift, as you can imagine. So we're covering more than we initially thought. Frankly, for instance, I'd suggest one vehicle would do everything if you only had a recording every 4 weeks, something like that. Different routes are choosing different frequencies. I'm sure Colin will correct me if I'm wrong,
Yeah,
but
so, I think you're right, Brendan. So we've got in the plan by 8 or 9 in CP7 nationally, and I think it's that iterative approach, which is you can't physically get the train to cover the entire junction in every turnout everywhere. So it's very much a hybrid mix of everything. So it doesn't cover the full manual inspection, so you have to integrate it with a visual tactile inspection just at a separate frequency. And we've kind of set our stall out to do 50% offset junctions, but that will evolve. So as we get familiar with it, we can hopefully relax the requirement for the manual inspection part, but that means more trains. But you need to make that business case now, which is that sort of how many do you need? But I think over CP6 and into CP7, if we have 2 per route or 2 per region, we'll cover enough S&C to really make that step change, and then prove to the regulator and everybody else who needs to fund it that this is the future, and actually unlock even more. So we've not done we need 15 or 20 in 20 years' time. It's very much, let's start with 2, 3, 4 in the control period, move on to 8 or 9 next time round, and see where it goes after that. Because you can kind of see if we can fit it to a 153, as technology evolves, can you fit it to a passenger train? Can you, what's the push? And there's no boundary to that. So what is it? What does that look like? And in the end, if in 10 years' time we don't have a 153 with bits of kit on various different passenger trains that all add up into, there you go, Timmy, here's an amalgamation of all the data presented for you, that's utopia. But it's kind of work in progress, and we're not ruling anything in or out.
Fantastic. Anyone else in the room like to ask a question?
So just to repeat another question, again a simple one. What's the operational running speed? Is it light speed, or is it going to be less than that?
no, it's as fast as the vehicle will travel, which I think the book speed for a 153 is 75, but I don't think any of them have seen that for a very long time. So yeah, it records exactly as you've seen there. The image capture looks the same at 70 as it does 5. Over S&C, the line speed's likely to be much slower, which I guess will aid it. But yeah, but there's no restriction on speed at all.
Okay, thank you.
Have you got some online questions?
We've got some questions in the chat. One from Stuart, just asking, I think if you could repeat it, Brendan, as to why the unit needs to be powered at all times.
Yeah, there's especially with these vehicles where you're changing stuff quite a lot. It gives you the ability to dial into them and make changes when the vehicle's not running, which can be quite a lot of the time depending on what it's doing. The other thing is that data can amass, so having the vehicles on all the time gives you the opportunity to transfer that off without any problem. And kind of one of the failure modes of technology is stuff keep being turned on and off. A lot of hardware's really made to remain on and doesn't like being turned on and off all the time. Certainly an issue on the yellow fleet. So we wanted to get rid of that as being a problem. So it's just kept on permanently. And with it being on batteries, you don't get complaints of the generator being on when it's berthed in stations or, from the line side neighbours. That's main reason, really.
Thanks, Brendan. There's a general question. I think I might be able to, you'll answer it better, but I might be able to fill in some of the gaps in one of the questions about why it hasn't been fitted to our existing fleet of inspection vehicles, but principally that's something about capacity and agility of our current inspection vehicles driving the need for you to explore other units.
Well, I guess so. The existing fleet is maxed out, Brendan, isn't it? And we have challenges around keeping that to deliver its core requirements as it is. So experimenting with an existing train was not an option. We needed to experiment with something that was completely separate, that didn't impact the plan. But as I say, I don't think we've ruled anything out for the future around what does a future recording fleet look like if it's going to be a hybrid of bolted on stuff to this train, moving some of this tech into the future upgrades of the PLPR and the NMT and everything else that is coming in the next 2 control periods. Passenger, we want kind of as much capability as possible with as many trains that run on the network to gather all the information as we need. So I think it's really don't try anything new on an existing train because you need it for core safety inspection.
Thank you, and that's kind of touched on with another question about people asking about ultimately could it be fitted to passenger trains in the future, and kind of don't rule it out is a message from it. There's a very detailed question here, which well, we'll see how we get on. Did the track circuit assistant create EM interference that had to be mitigated in specifying and designing the inspection instruments?
No, it didn't. It doesn't have any effect at all. So I think the EM shielding of modern equipment is not phased by that whatsoever. So yeah, as you could see on that photo, the Vista system's actually surrounded by the actuator antenna, and no problem.
Thanks, Brendan. And I think the last one from the chat is was consideration given to sustainability and carbon reduction with the overhaul of the units, i.e. what considerations were made for alternative fuel or energy efficiency on board?
Yeah, it was, and that was one of the drivers of having the batteries there. So we didn't have the generator on all the time. We've also looked at biofuel, and there is the intention in the future to run it on that. So the generators can run on it, and they are Euro 5 compliant as well. So much more efficient than anything's been in the past. So yeah, I think the only thing that stops us with biofuel at the moment is the availability of it around the network. We could use it at when it was available, but there's not many places just at the minute.
Thank you. I'd like to take Section Secretary's rights to ask a question as well, or privileges to ask a question. I've had an advantage of seeing a bit more of this than Brendan managed to brilliantly squeeze into a short section of time, and what impressed me as much as the technology that you've introduced is how you've introduced systems that are so smart to support it. For the example being how the sort of patrolling can be managed via the user interface in Ava, and I guess really it's just, having been through several painful experiences with introducing systems within Network Run in the past, just what hoops did you have to go through, or what insight did you need to choose suppliers that were going to produce something that was so intelligent and so practical for people to use?
Yeah, well, I guess we chose suppliers that had a good pedigree in the area, and we had worked with them all individually previously. The geometry system, for instance, we had that in the UK on trial, but could never just find a place to use it. Network have grown the Ava product with One Big Circle recently, so I'll be honest. Time time pretty much dictated who we went with and why. And one of the big things, as I mentioned in the clip there, was people that were prepared to run at risk with us and didn't need a detailed specification of exactly what they were going to provide up front, and they were along for the journey as well. So in terms of hoops, not many, because it's new, it's not been done before. As I mentioned, standards were looked at in parallel with it, and are currently going through to accommodate this as a potential alternative, with some caveats on frequency and so on. And a lot of stuff I found out new. So, you know, the developing interface, we've had to use the capability development team within Network Rail that issued us a set of sort of instructions and guidelines as to what we needed to take into account. But the biggest thing's been involving really the end users in it. So we were clear almost from day one, where we sort of held weekly steering groups with people in the route about what it was they needed to see and how they wanted to see it. And that's continued. There's always been plenty of dialogue and iteration and that kind of stuff. So I just think it's a reflection now on sort of what's achievable. You know, a lot of this tech's becoming mainstream, and I won't use the term simple, but you know, it's easier to deploy now in a more user-friendly fashion. I just think the time's right.
I just think to build on that, I think the credit to the One Big Circle team and Brendan to actually the usual processes are run through various different filters. What we've ended up doing is engaging directly between the owner of the architecture, listening directly to track inspectors, giving them direct feedback, and not just closing them down, but listening, taking it on board, trying it, coming back and iterating it. So it's been those leading conversations, but direct between track inspection staff and the designer, not through various different real project managers and project engineers who interfere and think they know better. There's a direct cut all that out, and we've ended up with a user interface that is actually a user interface, not what somebody thinks is a user interface.
So can we capture that? Because it's been really refreshing to hear how, if you like, the normal commercial processes haven't helped this project.
They have threatened it at times. So yeah, there have been some challenges. I think as Brendan's kind of alluded to, we've upset a few people through this process, and we've had to kind of keep going with the momentum of it.
And has that, I don't want to prod too hard with this, but has that needed, if you like, exec level support to help that to happen, or is it something you've been able to manage at project level?
I think on occasion it has required exactly that, people to bring decisions together and get them made quickly. This project is part of a wider program called the IM program, which is aiming to do exactly what you've mentioned there, which is challenge the way stuff's being done traditionally, and the way we engage with suppliers and contract with them is one of their main focal points. So this has kind of been a bit of a front runner for what they're trying out. So there's plenty of we're providing plenty of the learning back into that loop as well. So it is being captured more formally by the IM team.
I'm really upset that you're not down here, because I want to lasso you, take you down the pub and give you a jolly good interrogation. I guess we'd better draw the meeting to a close, unfortunately, just because we're pushed for time. What an inspiring, exciting, modern and frankly wonderful presentation. Absolutely excellent. What a terrific project. And all credit to all the people who've been involved with it, and Colin, credit to you as well for having the vision to push that through within the region. So terrific. I hear that the innovative mini documentary in the middle has been nominated for a BAFTA. So stand by your email box and see where the one arrives. And I really hope that as you started off your presentation with the Hatfield example, that this can be a spur to a cascade of improvement through the whole inspection process, which would be really, really welcome. So if you'd like to show Brendan your appreciation for his talk. Excellent stuff. Thank you very much indeed.
Thank you, Brendan.
Thank you. Thank you.
No worries. Thank you for all your time. Nice to have seen you all.
Yeah.